Surviving a tidal bore, a surging wave of water moving upstream in a river, primarily involves getting to high ground or finding a stable structure to hold onto. If you're in the water, try to grab something that floats. If you're on a boat, head out to sea or inland to a harbor if possible. Here's a more detailed breakdown. 1. Get to higher ground. Evacuate inland. The most important step is to move away from the riverbank and seek higher ground as quickly as possible. Find elevation. If higher ground isn't immediately accessible, try to find a tall, sturdy building with a strong foundation and get to the highest possible floor. Don't rely on swimming. A tidal bore is powerful and can easily overwhelm even strong swimmers. 2. If caught in the water, grab something that floats. If you're caught in the water, try to grab onto anything that floats, like a large piece of wood, a life raft, or even debris. Use your legs to steer. Try to use your legs to propel yourself towards a safer location or towards something you can use to get out of the water. 3. If on a boat, head for deeper water. If you're on a boat, head out to sea away from the shore. If in a harbor, head inland. If you're in a harbor, try to get to the shore and then move inland. 4. Be aware of your surroundings. Listen to local authorities. Pay attention to any warnings or alerts issued by local authorities. Observe the water. If you see the water receding suddenly or a large wave approaching, evacuate immediately. 5. Prepare in advance. Know your local area. Understand the areas that are at risk of tidal bores and identify safe evacuation routes and zones. Have a preparedness kit. Prepare a kit with essential items like a radio, flashlight, first aid supplies, and water. Important considerations. Tidal bores can be dangerous. Even though they are not as large as tsunamis, tidal bores can still be powerful and cause significant damage. Be prepared for multiple waves. Tidal bores often occur as a series of waves, so be prepared to stay in a safe location until authorities declare it safe to return. Tidal bores form when a strong tidal wave propagates up a narrow, shallow river or estuary, creating a wave that travels upstream. This phenomenon occurs in areas with a large tidal range, the difference between high and low tide, and a funnel-like shape that constricts the incoming tide. The incoming tide's force, when funneled and concentrated, can exceed the river's current, causing a wave to surge upstream. Here's a more detailed breakdown. Large tidal range. Tidal bores require a significant difference between high and low tide, often more than 6 meters, 20 feet, according to Wikipedia. Funnel-shaped estuary. The estuary or river mouth must narrow and shallow as it approaches the ocean, concentrating the incoming tidal surge. Tidal wave propagation. The incoming tide creates a tidal wave that travels up the river. If the tidal range is high enough and the estuary is funnel-shaped, this tidal wave can become a powerful bore. Upstream movement. The bore's speed is influenced by the riverbed's slope and the tidal range. In some cases, the bore can travel upstream at speeds exceeding 30 km per hour. Visual appearance. Tidal bores can manifest as a wall of water, sometimes breaking like a plunging breaker, that surges up the river. Tidal bores typically stop due to a decrease in the tidal range, a change in the riverbed's shape, or the natural dissipation of the wave's energy. As the tidal bore travels upstream, it loses energy due to friction with the riverbed and the surrounding water, and eventually, it may become too weak to sustain itself. Additionally, the funnel shape of the estuary can become less pronounced, and the slope of the riverbed can change, reducing the bore's ability to propagate. Here's a more detailed explanation. Decreasing tidal range. Tidal bores are most prominent where there is a large tidal range, the difference between high and low tide. As the tidal bore moves further inland, the tidal range generally decreases, reducing the energy available to maintain the bore's momentum. Changes in riverbed and estuary shape. The funnel shape of an estuary plays a crucial role in concentrating and directing the tidal bore's energy. As the estuary widens or the riverbed becomes less steep, the bore loses its ability to focus and propagate effectively. Friction and dissipation. The constant interaction of the bore with the riverbed and surrounding water causes friction, which dissipates the wave's energy. This energy loss reduces the bore's height and speed until it eventually stops. Flow conditions. The velocity of the ebb, outgoing, tide can also influence the bore's strength. If the ebb current is strong enough, it can counteract the incoming bore and reduce its progression or even cause it to break. Natural obstructions. Natural features like sandbars or shallows can also impede the bore's progress, causing it to slow down and eventually break. Local factors. Human-made structures like weirs, dredging, or reclamation projects can also alter the riverbed and affect the formation and propagation of tidal bores. Tidal bores can be very dangerous, especially for those who underestimate their power or fail to heed warnings. While not as powerful as tsunamis, they can still cause significant damage to ships, flood coastal areas, and pose a risk to anyone in or near the water. Surfers and spectators can be caught off guard by the sudden surge of water and powerful currents. Here's a more detailed look at the dangers. Surfing and water activities. Tidal bores can create powerful waves suitable for surfing, but they also pose significant risks. Surfers can be caught in strong currents, pulled underwater, or swept away by the wave. Boating. Boats can be capsized, swamped, or swept away by tidal bores, particularly in narrow channels or rivers. Flooding and erosion. Tidal bores can cause rapid flooding of coastal areas, inundating roads, homes, and businesses. They can also erode shorelines and damage infrastructure. Drowning. People can be swept away by the force of the bore, leading to drowning, especially if they are caught off guard or ignore warnings. Damage to structures. Tidal bores can damage or destroy docks, piers, and other structures along the coastline. Impact on wildlife. The turbulence and flooding caused by tidal bores can disrupt ecosystems and impact wildlife habitats. Examples of dangerous tidal bores. Qiantang River, China. This tidal bore is renowned for its size and power, with dozens of fatalities each year due to people ignoring warnings and getting swept away. Tanagan Arm, Alaska. This is a popular spot for viewing tidal bores, but the force of the bore can be dangerous, especially for those attempting to surf it. Seine River, France. Historically, tidal bores on the Seine were responsible for numerous shipwrecks and damage before river management systems were implemented.